In this video, we're going to use exponential functions to figure out how long it takes to double our money or lose half the value of our car. Let's read through this word problem carefully. The exponential function below, f of z, describes the value in thousands of dollars of a car in z years since you bought it. So z is for time, and it's how many years it's been since we bought the car. Use it to approximate how long it will take for the value of the car to decrease to half its original value. Keyword there. Round to the nearest integer, so no decimal places. All right, now notice what it doesn't tell you in the word problem. It doesn't tell us how much the car was worth in the beginning or when we first bought it. So we can use our function to figure that out. So in this case, when we bought the car, z would be 0. So let's figure out f of 0. So we're going to plug in 0 in for z on the right side. Now anything to the 0 power equals 1, and this exponent only applies to the 0.9. So 0.9 to the 0 power equals 1, and 31 times 1 is just 31. All right, so this number here was our beginning value, or what the car was worth when we bought it. Now we're wondering how long it will take for the value of the car to decrease to half its original value. So let's figure out half of 31. So 31 divided by 2. That will be 15.5. So half of 31 is 15.5. All right, so we're wondering how many years it takes for the value of the car to drop to $15.5 thousand. So 15.5 is actually the output for this function, because this function is telling us how much our car is worth. So we're going to have f of z be equal to 15.5, and that will equal this function here, 31 times 0.9 to the power of z. So we're trying to solve for z, but it's in the exponents. So let's get this exponential term all by itself, so we'll divide by 31. And 15.5 divided by 31, well, that's equal to 0.5. All right, let's go ahead and rewrite our exponential equation using logarithms, and that will help us solve for z. So I have the log base 0.9. It's the base in the exponential equation. It's the base in the log of the number that is not the exponent, and that equals the exponent. The log equals the exponent. All right, we're ready to solve for z. Most scientific calculators do not have a button that allow you to choose the base. So we will real quickly use the change of base formula to evaluate this logarithm. So z will equal, let's see, we'll use base 10, because when we use the change of base formula, we get to use whatever base we want. So we have log base 10 of 0.5. And when we use base 10, we leave the 10 out. We don't write it. Over log base 10 of 0.9. So the change of base formula allows us to use our scientific calculator to do this calculation here. All right, so we have log of 0.5 over log of 0.9. And that's equal to about 6.579. The question asked us to round to the nearest integer. So z is equal to about 7. We round that 6 up to a 7 because the number after it is 5 or bigger. All right, so we just figured out that it's going to take about 7 years for the value of our car to be half of what it originally was. Write the exponential function below, f of y, describes the number of boba shops in Bakersfield in Y years since 2020. Use it to predict how long it will take for the number of boba shops to double. Round to the nearest integer. Now we'll need to use this function to figure out how many boba shops there were in 2020, and maybe we can figure that out just by looking at the function. But let's go ahead and calculate that. So 2020 would be 0 years since 2020. So let's figure out f of 0. So we'll plug in 0 for y. Now anything to the 0 power equals 1. So in 2020, there were 15 boba shops. All right, we are wondering how long it's going to take for the number of boba shops to double. Well, to figure out double of something, we multiply by 2. So we're wondering how long it's going to take for there to be 30 boba shops. Okay, so our output, or the number of boba shops, will be 30. That's our left side here. And that will equal 15 times 1.17 raised to the power of y, because we don't know how many years yet that it's going to take to get to 30 boba shops. Let's get this exponential term by itself, so we'll divide by 15. 30 divided by 15 equals 2, closely related to the word double there. Now to figure out y, let's go ahead and rewrite this with logarithms. The base is 1.7, so the base of our logarithm will also be 1.17. Of the number that is not the exponent is equal to the exponent. Right now, since most scientific calculators don't have a base 1.17 button, we'll go ahead and use the change of base formula. So that will be log base 10 of 2 over log base 10 of 1.17. And we get about 4.415. And we want to round to the nearest integer, so no decimal places. That'll be about 4. So it's going to take about 4 years for the number of boba shops to double. I hope this video about using exponential functions to figure out how long it takes to double our money or lose half the value of our car has been helpful. This is Mr. Ela, signing off.